Hey, cool. One of the big problems with crypto and on-chain data is that it's very hard for it to interoperate with the systems that we're used to, the Web 2 systems. Currently, in order to do that, you often have to have an attester. This central third party often undercuts the decentralization of whatever on-chain application you're using. And so it's very difficult to actually bring that data on-chain in a verifiable manner without having to trust things like MPCs, oracles, or enclaves with the security of your application. But instead of attestations, what if there was a way you could use provenant data instead? So today we'll be talking about ZK email, portable provenance, and how you can use that to power wallets, account recovery, and more. I'm Aayush.
And I'm Sora.
And thank you to the literally dozens of people who helped this project happen. We wouldn't have been able to ship account recovery today without the help of all of these folks. So during this presentation, we'll talk about a few core topics. First, we'll discuss core ZK email and how the cryptographic primitive itself works. Then we'll explain how we use ZK email to build email wallet, which lets you send money to email addresses and use emails to trigger transactions. Then we'll explain how we generalize that to do account recovery, which allows you to have a signer, which is an email wallet guardian on your existing wallets. If you want to follow along with the slides, feel free to scan the QR code, and then you can pan forward, backward, wherever you want in our slide deck as well. So how exactly does provenant data work? Well, the idea is that because the email is signed by the off-chain service that sent it, we can actually verify that data directly, giving that data provenance. Now, if we prove that email signature within ZK email, we can make it portable. That is, we can prove it on-chain directly. We can also make it programmable. We can decide if we want to reveal certain information or not reveal certain information. For instance, maybe we want to hide the from email, but we want to reveal the to domain, and we want to hide parts of the subject. We can use arbitrary logic to program it with ZK regex. But how does this actually work? Well, the idea is when any user on any email domain server sends an email, an RSA signature is automatically attached to every single email that you've sent or received since 2017. We can verify this email by the recipient in a ZK proof, where the recipient can then prove that they received an email from, say, @zksummit.org without revealing anything else about the email. Then they can directly post this ZK proof on Ethereum to do whatever they would like with it. Cryptographically, how precisely does ZK email work? The idea is that every single email is signed according to the DKIM protocol. This is effectively an RSA signature of the SHA-256 hash of all the data in the email. This would include the from email, the to email, the subject of the email, and the hash of your whole email body, including the attachments. This SHA-256 is then signed with by the RSA private key of the domain. To verify this in ZK email, we verify this entire process. We verify the RSA signature and the SHA-256 hash in order to verify that the DKIM was done correctly, and then we run regex in order to mask only the data and reveal specific pieces of information. When you want to verify this whole thing end-to-end, you verify it against the RSA public key, which is found on DNS. So for instance, for example.com, you might find it at selector.domainkey.example.com. So for a concrete email, how might this verification look? You can imagine that often on-chain people want to prove information about identity. For instance, what is my Twitter username? How many followers do I have? Something like that. So to get that Twitter username on-chain without having to trust any party except Twitter, we have an email here from Twitter. Any email would work, but in this case we have an on-demand password reset email. You'll notice that at the bottom right, it has my username. In order to prove this value on-chain with ZK email, we would first take the headers, the subject, the from email being verified, twitter.com, the timestamp, etc. We'll hash that for you, and then we'll verify that hash was done correctly and verify the DKIM signature. Then inside the body, if we want to prove things about the body, we can take the point in the body that we want to prove from and hash that forwards and ensure that that value was in fact signed by the header. Then we can run our ZK regex proof on that to verify that the data we're looking for is in fact in that email. And then we use regex to extract the specific value you want to prove on chain. In this case, this proof would, at the end, prove that I own the username UshG. You can build a number of things by this primitive that allows you to prove any email in your inbox. For instance, ZK P2P, which most ZK Summit folks are familiar with, allowed you to build decentralized on and off ramps by proving a confirmation email from Venmo, UPI, or Guarantee, which allows you to move Turkish lira, US dollars, or rupees directly on and off chain. You can use similar technology to do email wallet, which allows you to basically, by proving that an email was sent, send money to any email address and allow them to claim it by simply replying to an email. If you want to see links to these projects, you can go to prove.email or zkp2p.xyz or emailwallet.org directly. Let's dive in a little bit to email wallet and how precisely you might do a system like this. You'd imagine that off-chain, what is happening is, say, I@gmail.com, I'm going to email a relayer, which could be myself, or any third-party relayer, and that relayer can then send a confirmation email to the recipient, in this case, my friend at outlook.com. In the Web2 context, it would end here. But with ZK email, the relayer can simply make a ZK proof that they received that email and subsequently prove that on Ethereum. This can then gate a transaction, in this case, 3 USDC going from my account to my friend's account. You can try out emailwallet.org on the bottom right if you scan the QR code. And the core idea is that by replying to an email, you can trigger a transaction. So for instance, when you log in, you might get an email that looks like this. In order to create your account, just reply to this email with any text. And one of the really critical things here is that there's an account code in this email. It can be in the body, but in this case, we have it in the subject.
And this account code is a critical feature of email wallet for its privacy protection and layer decentralization. Specifically, our ZKP circuit computes the hash of the email address in the front field and the account code. And this hash is used as the credit sort of the user's corresponding Ethereum address. So our adversary cannot estimate the email address in the corresponding to the public Ethereum address because this account code is a random value. Also, the circuit checks if the user's account code exists in the user's email header. So it ensures that the user can actually access to the account code. And this allows the layer decentralization because it prevents malicious layer from withholding the account code to users. In other words, as long as the user can access to the account code, the user can use different layer just by sharing the same account code to a new layer, even if the current layer censors the user's transactions. So we go back to the flow of the email wallet. After creating your email wallet account, you can log into this account just by pushing this button in the layer's email. And this will autofill the account code into your front end. And on the front end, you can transfer tokens from your email wallet account by filling the amount of token and the kind of token here and specifying the recipients either by the Ethereum address or email address. So in this way, you can transfer tokens directly to your email address. And by pushing this send confirmation email, you will receive a confirmation request email from the layer. And just by replying to this email, your transaction will be complete. And your token in the email wallet contract will be transferred on-chain. And similarly, we demonstrated a demo of the sending NFTs to email addresses at each number. So the background flow of these applications using email wallet is illustrated like this one. So the sender, Aayush@gmail.com, first sends email to the layer's email address. And the layer creates a ZK proof using the given email and the user's account codes. And this proof is verified by the email wallet contract on-chain. And if the proof is valid, actual tokens are actually transferred on-chain. And after that, the layer sends email not only to the sender, Aayush@gmail.com, but also to the recipients. And if the recipient does not have an account yet, it will create a new account code for these recipients, and the reuse email contains this account code. So the recipients can claim this receiving token just by replying to the email. And even if this layer goes down or senses the user's email and the transactions, the user can start using different layers just by sending an email with the account code to a different layer's email address. So our layer of email wallet can be already decentralized. So this is the description about the background of email wallet. And now we are ready to announce our new product, that is on-chain email auth SDK. It generalizes the features of email wallet, and it allows developers to build email-based on-chain application without writing new circuits, just by writing solidity contracts. So specifically, your smart contracts can handle an email as a kind of on-chain message with confirming that the message sender's Ethereum address is corresponding to the user's email address in the from field, along with some account code. And at the same time, the given parameter values in this message are actually contained in the user's subject. And this subject is following some format predefined by each application. And the magic to handle application-specific subject format without preparing new circuit is this subject template. So this is the example of the subject template. You can see there are some variable paths like dismounts or strings whose values are depending on each subject and which has some types like these ones. And also there are fixed string parts whose value is static. And you can define your custom subject template by combining these variable paths and the fixed parts. And you can define this subject template directly on the solidity contract without writing any circuits, just writing solidity contracts. So for example, if you want to make an application like to transfer a specific amount of tokens, or you need a confirmation by the email or email's confirmation, then to construct such two-factor authentication system using emails, you can put the information of token amount or name of the token or some transfer ID into the subject by defining each good subject template in this way. And in this way, our email SDK, this SDK converts users' interactions to contracts into a task just to send email. And after defining your custom subject template, our SDK will automatically verify this subject. Specifically, we verify that our SDK verifies that the subject is actually included in the user's email, and at the same time, it follows the predefined subject templates. And how to do that is, first, its circumcircuit receives email header and outputs the entire email subject with masking some private data like email address and account code. And in contrast, the contract will receive parameters for the variable parts, which is just the call data for the solidity function and the subject template itself. And based on these data, the contract will construct expected subject. And if and only if this masks the entire subject and the expected subjects are equivalent, it passes the verification. So for example, if the subject template is a kind of swap decimal string to string via Ethereum address, then the circumcircuit will output the entire subject without modification. And contract will receive the parameters of each variable path, like 1.23 for decimal paths and is for the string parts. And it applies these valuable parameters to the valuable parameters to the valuable paths of the subject template. And in this way, it can construct expected subject. And you can see this masked subject and the output of the circuit and the output of the contracts are equivalent here. So in this way, you can easily define your custom subject template using our SDK. And one of the big killer application of our email auth SDK is email-based account recovery. This is a kind of social recovery, but guardians only need to use emails. So the problem of existing social recovery is the guardian should be a trustworthy person for the wallet owner, but not all of them are always Ethereum users. So our email-based account recovery enables any email users to work as guardians. So you can specify most of your trustworthy person, such as your parents, your best friends, and so on, as a guardian of your Ethereum wallet. So in this sense, we make social recovery practical solution.
To describe more about how the specific account recovery might work, you could imagine that when a user wants to set an email guardian, that guardian would get an email asking them to confirm. When they reply, the email auth subject template would be confirmed and proved on-chain. Similarly, when the user wants to recover the wallet, they might get an email like, confirm that you want to recover the wallet from one address to another address. They would simply reply, that would get proved on-chain, and the wallet would recover. We have a demo of the proof email recovery with Nose Safes on base Apolia right now, and we'll walk you through how exactly this might look from a user perspective. You can imagine that for Nose Safe, we have our own website and people can integrate with it, and you'll need a Nose Safe with on base Apolia to try out the demo. But you'd imagine that for an existing account abstraction wallet, they could embed this directly into their application. For Nose Safe, you would have to enable the email recovery module, which would add this email signer as a signer on your multi-sig. Then you would simply set all the different guardians you want to set by just entering their email address, and then a recovery delay. The purpose of the recovery delay is that you want guardians to request to recover the email, and then only say a day later, the account gets recovered. This means that it allows time for all of the guardians to take time to agree to recover your address at the same place. And if a specific guardian has been compromised, it gives the wallet owner time to override the compromised guardian's actions. Once you've configured this guardian and the delay, that guardian will get an email like this. It simply asks if the guardian wants to be a signer for this account. When the user confirms, we would parse that email on-chain and ensure that the email address from that email corresponds to the wallet address specified in the email and add them as a guardian on the multi-sig. Now, let's say you've lost your wallet. When you want to recover it, you would simply, you or the guardian can enter the guardian email address, the previous wallet owner, and the new wallet owner into the UI. And when you hit trigger recovery, then the guardian will get an email asking if they want to confirm this operation. It would ask them if they want to update the owner from one address to another address, and again, if they reply, then it's confirmed on-chain. Again, the email subject parsing parses those two values and recovers the owner from the old owner to the new owner automatically. Now, this account recovery is quite easy for new account abstraction wallets to integrate. The way we've abstracted it is there's only 5 functions that a new AA wallet or multi-sig needs to implement on their side. You can see the full spec of how we do it and the technical details on the right side if you want. But this makes it very easy for a new account abstraction wallet to automatically add email guardians. Now, this email auth package and SDK is extremely generic and powerful. It doesn't just handle account recovery. You can trigger any transaction you want on-chain by sending emails. This adds quite a lot of power because the ability to both authenticate the email was correct and the operation they're performing was authenticated by them in plain text gives you a whole new field of operations you can do with existing wallets. For instance, you can ask users who aren't on-chain users to confirm certain transactions. Maybe you're working with banks, or maybe you're working with governments, or whatever it is. You can ask them, who may not be chain native, to still interact with your application just by confirming via email. You could also secure different contracts. For instance, if you have a bridge, you can say any transaction over $1 million has to be confirmed by a set of email addresses in order for it to pass. And so the general ability for anybody with an email address to interact with an on-chain application fundamentally means you have a whole new space of users and a whole new space of operations that you can enable on your smart contracts. For account recovery specifically, we also have the SDK that lets people integrate the version of this package that works just for account recovery with only Solidity functions. We've currently built it at Ether email auth. We'll release it as a more formal NPM package once our audit is finished this month. Over the last year to year and a half, our ecosystem has massively expanded. This is quite an overwhelming graph, so I'll just go piece by piece. The purple stuff in the middle is the things that allow you to create a new ZK email proof or ZK email mechanism. This includes the core ZK email contracts, DKIM archive of all past DKIM keys so you can verify old emails, and ZK JWTs that allow you to verify, for instance, that you own an @zksummit.org domain without revealing who you are. And of course, the Ether email auth package. Various things have integrated this, for instance, email wallet, proof of Twitter, and the account recovery that we mentioned. But there's also a number of primitives on the far left side that you can use to build apps that are generally for proofs of ZK signatures and not just ZK email. For instance, you can use regex to parse any information in a structured language off-chain and bring that information on-chain. For instance, you could use this on different data you get that you already have a digital signature on outside of ZK email. We also have WASM benchmarking code. And we have a ZK PSI library that we use for relayers to communicate private information to each other. This is one of the things that allows decentralized relayers to be much easier to do because they can have a private way to share that private information without revealing the entire thing. And we have libraries that allow you to do this ZK PSI operations. This can be quite powerful for relayers outside of the ZK email context where you still want to decentralize them. We also have a number of string parsing and signature libraries that allow you to make new ZK proofs. A number of projects have integrated various parts of this, including ZK P2P, Nosy for anonymous discussions, proof of passport, and a whole host of other applications. If you want to see a deeper dive into the ecosystem, you can check out our blog at proof.email/blog, where we describe in depth how each one works. For the core ZK email circuits, if you want to use them, we've currently published CIRCOM and Halo 2 versions. Why CIRCOM and Halo 2? We published a long blog post explaining how we had decided if we want to be in production, what is the most both battle-tested, fast, and easy to interact with libraries. We expect this to change over the next 6 months to a year as new proof systems get audited and put into production. But if you're interested in looking at the trade-offs between different proof systems we made to understand which ones to focus on, we have a long summary here. This is also expected to change over time. For CIRCOM, it's extremely fast on the server side for us, and it's been audited once, and we're going to audit it again this month. And this allows you to build, of course, the ZK email circuits and the ZK regex compilers and APIs. Halo 2 allows you to have super fast client-side proofs, and that will be audited soon. If you want to see these repositories or integrate with them or import them, you can check out our GitHub on the right side. Everything is MIT licensed open source. We have various tooling. We have the historical regex registry that has over 100,000 keys now that lets you verify past DKIM keys and stores them. And there's still dozens and dozens of applications you can build with ZK email. We've only scratched the surface. You can imagine that any email in your inbox can be proven. That includes maybe you took a flight and you want to prove you took a specific flight that was, say, carbon neutral or something. You can make a ZK email proof of that. Or you can prove your credit score on chain by proving you got an email from a credit organization saying your credit score was some value. You can bounty whistleblowing. You can put a bounty on anybody posting an email from a specific sender with specific text on chain to incentivize people to whistleblow. You can donate to papers or GitHubs because you often have the emails for these people, even though these people may not have on-chain accounts, allowing you to do mass donations or mass onboarding. And this is still just probably 1% of the number of emails in your inbox, of which you can make dozens and dozens of proofs of. So we would love to support people building projects. We'd love to jam on ideas. If you check out our GitHub, we have tons of different things we're looking for help on and like dozens of project ideas. And we would love to just chat. If there's a cool email in your inbox, like we want to hear about it. Let's make some proofs of it. There's again a QR code to our GitHub if you want to check out more of these ideas. So what's next for the ZK email team? After our audit this month, we'll be focusing on integrating account recovery into as many wallets as we can. So if you are a wallet or you know a wallet, we would love to add email guardians to them. After that, we are thinking about doing OAuth with emails, in the sense that you can now log in to any website and authorize any specific scopes by just responding to an email in a Web3 native way. For instance, maybe you're logging into a website and you only want them to access your ERC20s for one specific contract, or you only want them to be able to operate between the hours of 12 and 8 every day. You can specify that information as an OAuth scope, and the user can just confirm it by replying to an email. This can be super powerful for logins working in a completely decentralized manner, where you define your own scopes. And we'll be working that May and June. If you're interested in integrating email login generally into your app, we would love to chat more about that. We'll be doing a signature singularity residency in which we know that ZK proofs of general signatures are super powerful even outside just ZK email. And so we're working with a number of teams doing ZK signatures in order to run this residency, including Cursive, who's doing the cards that we're signing at ZK Summit. And then finally, we'll be focusing on universal regex verifiers, which allows you to have a single contract on-chain verify any ZK-ML proof with any regex by using Axiom's pass-through verifiers, where you can just simply specify the verification key of that specific regex and use the same on-chain contract. If you want to chat more, we would love to chat. Our Telegram's in the top right, and these slides are in the bottom left. Definitely let us know if you have any questions, and we would just love to jam on different ideas. Thank you so much.
Okay, thank you, thank you. We have a few minutes for questions. Any questions? There's the mic on your seat, just make sure it's on. Oops.
Okay. Hi, thank you for the presentation. It was very insightful. One question I have is, what are, let's say, the possible ways to spoof this? For example, especially since we're meddling with things like guardians and wallets, right? Anti-spoofing should be a big concern. So I'm not an expert in this, but I've heard of DKIM spoofing before. So is this something that's a challenge with the current stack? And what are the ways you think you can tackle this?
Yeah, so it's a great question about how do we get around things like DKIM spoofing. So if you look at a number of the DKIM spoofing libraries and techniques, for instance, the one released at DEF CON last year, often these DKIM spoofing techniques rely on changing different headers to disable the DKIM check. And that's how they get around these checks. But in order to spoof DKIM in reality, you would have to have that domain's private key. And when domains find out that somebody has their private key, they will often just rotate that value. And so it's actually the case that most DKIM spoofing is not faking the DKIM signature that we verify. And we've gone through tons and tons of different email exploitation mechanisms, and we found that ZK-ML actually still verifies every single one of them because nobody can fake the DKIM RSA signature. But it's a great question, and if you find a way around it, we're happy to chat. But from what we can tell, domains will immediately rotate.
Okay, we have time for one more question. Just press the button, make sure.
Okay, great. Really nice work, really exciting project. I had a question about how do you agree on the public keys of the email server on chain to do the verification of the signature?
Yeah, it's a great question. That DKIM public key is usually stored on DNS, and so getting that value on chain, there's a couple of different ways we can do it. One is that you can delegate that responsibility to the app. So for instance, if people trust that the app wants to say verify that DKIM signature, they can trust, okay, the app has set my DKIM key correctly. The other cool thing is that we can have user-specific overrides on that DKIM contract. So if you don't trust that the app has set that DKIM public key correctly, a user can specify, for instance, if you want to verify anything with this address, it has to be by a DKIM key that I've authorized. And so folks who don't necessarily trust their infrastructure or the app to put those keys on chain correctly can simply say, I only want you to use these keys that I've allowed. And so for privacy conscious folks or security conscious folks, that might be a better option. And so the idea is that DKIM key value is usually punted to the users, the apps, or the protocol. It's a great question, though.
Okay. Thank you so much, Aayush and Sora from ZK Email. Give them a round of applause.